All right, hey Geo kids. We are going to talk about section 4.5 tonight, and it is on page 114 of your student journals. This is where we're going to start. So the last transformation we're going to talk about is called a dilation. And a dilation is something where either you make an enlargement, you either make the figure enlarged or you make the figure reduced. In other words, you make it larger or smaller, right? And what you do is you put this, it's always with respect to a fixed point. And so this fixed point is called the center of dilation. And so what a dilation does is it's the only one that's not a rigid transformation. And what I mean by that is the size changes with this type of transformation. And so unlike a rotation or a reflection or a translation where you just kind of, your end result, your image and your pre-image were congruent, these two are not going to be congruent. They're going to be similar but not congruent, which means that the size of the figure is going to be different. Now the angle measures will stay the same, but the size will change, whether it gets bigger or large or smaller. So we're also going to talk about something called a scale factor. So the scale factor is is how much you're either, enlarging your figure by or how much you're reducing your figure by. We use the value k to represent scale factor. And so what the scale factor is a ratio, which means a fraction, of the length of the corresponding sides of the image and the pre-image. So it's sides of the image over side of a pre-image. And so what we're doing here, we're going to talk about how we can kind of calculate that ratio. An enlargement basically means that you are making the figure bigger. And so in most cases, an enlargement has your k value being greater than 1. So think about like you're making it 3 times as big or 4.5 times as big. You're going to have a number that's greater than 1 in order to have that happen. For a reduction, your k value needs to be less than 1, but greater than 0. So again, you're going to make it half as big, 1/3 as big, 0.26 times as big. And so anyways, your k value is going to be less than or equal to less than 1, but greater than 0 in order for it to be a reduction. And so this little diagram here at the bottom basically kind of shows you if this were our pre-image. So remember, your pre-image is kind of where you start. And then this is our image, which is where we end. What we're talking about here is this is their center of your, the center of dilation. And they're talking about the k value being the ratio of the distance from your center to your image over your center to your pre-image. So remember what I talked about up here when we kind of talked about the scale factor. So what you're going to see me write and use a lot is this little ratio right here, which means k is the ratio or fraction of c to p prime over c to p. So c to p prime is this distance here over c to p. So it's the distance from the center to the image divided by the distance from the center to the pre-image. Let me go ahead and go through a couple examples with you guys. So we are going to go ahead and turn to page 115, and we are going to look at the ones here in the middle, the extra practice. So in these lovely diagrams, what you're asked to do is to find the scale factor and then talk about whether it's enlargement or a reduction. So for each of these, what I want you to pay attention to is like which one's the image and which one's the pre-image. So we have this figure here, so it's like a square, and then we have this figure here. So remember, your pre-image is always the one without the primes, and then your image is the one with the primes. So if we're going from here to here, we should already kind of know whether or not it's going to be a reduction or a enlargement, because we're going from a bigger figure to a smaller figure. So that means when you do your math, when you do the ratio, you need to make sure that makes sense. So remember the rule here for k, or your scale factor, is from c to p prime. So from c to p prime, that's this distance here, Well, if this whole distance is 4 and this distance is 2, that means this right here has to be 2 as well. So from C to prime is 2, and from C to P would be 4. That makes my scale factor a half. So if I'm going from the pre-image to the image, obviously we're getting smaller, so this would be a reduction. All right, next one. We have so this time, this is the pre-image, right? So no P's, and then the image is this larger one. So we're going from a smaller object to a larger object. So we should be expecting an enlargement. So K is C to P prime and C to P. So C to P prime is 25 and C to P is 20. So if I reduce that, I get 5/4, which is definitely bigger than 1. So this would be an enlargement. All right, the last one, I'm gonna leave this one for you guys to practice. So again, just kind of following the same order with 1 and 2, I'd like you to practice number 3. All right, number 4, I want to go over an example like this one. So it says, graph the polygon and its image after the dilation with a scale factor k. So I'm going to go ahead and start by graphing this original image. So it's a triangle. So -3, 1 is A, -4, -1 is B, and -2, -1 is C. So I have this triangle here, and now what I'm going to do is I'm going to go ahead and find my new image, right? So I'm going to find this is my pre-image, I'm going to find my image. I'm going to use a scale factor of 2. Another way you will see this written is with a rule. And so a scale factor of 2, what you're doing here is you're multiplying your x's by 2 and you're multiplying your y's by 2. So everything is scaled up by the same amount. So go back to your A value. If I multiply everything by 2, I get -6/2. If I multiply everything, the B value is by 2, and then the C. And so now I'm going to change colors here, but we're going to go ahead and graph this one. So this is at -6/2. That's A prime, and then -8, -2, and then -4, -2. All right, so notice that you have the same kind of look. So like the triangles look the same, they're just a different size. So this is what we call similar figures. They have the same ratio. So all of the side lengths are scaled up by the same amount, but their angles are all the same measurements. And so in that case, what happens here is that they're not congruent, obviously, because they're not the same size, but they are indeed similar. What I would like you to do is on the next page, so again, I went through number 4. Number 5 is very similar. So looks like there's 4, so you're probably gonna have some sort of quadrilateral, and then you have a scale factor here. Remember that, again, another way of writing this rule would be that you're multiplying both your x's and your y's by that scale factor. So I'll have you guys try number 5. All right, I'm gonna do number 6 here, and I'm gonna do number 8. So that way you guys can have a little bit of, you can see me kind of do one from each category. So number 6 and 7 says, find the coordinates of the image of the polygon after a dilation. Pay attention to this scale factor though. This one has a scale factor of -6. So pay attention to what happens to our figure once we dilate it. So I'm going to multiply everything by -6. And so I get A prime, B prime, and C prime. Well, I wrote over that, but that's 12 and 6. So what I get here, I go from -3, 1, obviously these numbers are getting bigger. So even though this number is -6, what happens here is when your K value is negative, it does the opposite, right? So even though it's a small number, what happens is that we actually end up getting an enlargement. All right, let's do number 8. So there's a couple here. I'll do number 8. You guys can try number 9, just like number 7. It says you design a poster that's 8.5 inches by 11. So I'm just going to draw a poster, and I'm going to do 8.5 by 11. Now you didn't have to write it exactly the way I did, but this is the way I'm writing it. And then you're saying that this poster is the winner to be printed on a 34 by 44 inch canvas. So what I'm going to show you here is if you're drawing a diagram, which I highly recommend, you want to match up similar sides, right? So if this is where I put the 8.5, that's the smaller of the two sides. Then when I do the 34 and the 44, I want to put the smaller of the two sides down there as well. So now my goal is to figure out my scale factor. So again, what I want you to remember is that you're going from the image to the pre-image. When you talk about your scale factor, it's always the ratio of your image over your pre-image. Also think about, well, what kind of scale factor should I expect? If I'm going from 8.5 by 11 to a 34 by 44, I'm obviously getting bigger. So therefore my scale factor should be an enlargement. Make sure that your answer matches what you think it should happen. So the image, and I really just have to take one of those sides. I'm going to take 34, and it matches with 8.5. Well, if I take 34 and divide it by 8.5, I get 4. That's definitely an enlargement. I can try it with this side. If I take, so that what's basically what I'm saying here is I'm taking both of those sides and I'm multiplying them by 4 to get to these sides. So 8.5 by 4 is 34, and 11 by 4 is 44. So I know that they match up, and so I know I did that problem correctly. All right, last but not least, we're actually going to skip ahead. We're going to do a little bit of 4.6. So I want you to find page 120 in your student journals for me, please, page 120. And with page 120, we're going to do a couple of these. So what this is a combo type problem. So I'm going to do the first one is a translation followed by a dilation. So a translation followed by a dilation. And then I'm going to do another one that's a rotation followed by a dilation. So I will leave you number 2 to do, and I'll do 1 and 3. All right, so first step, I am going to list my points. So there's 4 of them, A, B, C, and D. But I'm going to do the A prime, B, C prime, and D prime. And so the first transformation I'm doing is a translation. And I'm subtracting 5 from my x's and subtracting 3 from my y's. So I'm going to go ahead and do that. Subtract 3, I get 0. And then I get 0 and 2. So that would be my image. If I graphed that, that would be my image after my first transformation. But now I want to do a dilation. So I'm going to do A double prime, B double prime, C double prime, and D double prime, because it's my second transformation. And now I'm going to multiply everything by 3. All right. And then it does ask you to graph, so I'm going to go ahead and graph my original. So 3, 6, 2, 5, 4, 3, and 5, 5. So it looks like it was this kind of a quadrilateral here. I'm going to go ahead and graph my new image, or my final image. So negative 6, 9. Whoops. Yeah, I did that right. Okay. Wait, no, negative 6, 9. That one's here, not here. And then I did negative 9, 6. And then I did negative 3, 0. And then 0, 6. So you can see, if I connect all my dots here, that the images do look the same, you know, in terms of shape and so forth, the angle measures. But what happens is obviously we made it bigger. It's 3 times as bigger, and it's slid. It's kind of slid over because of the translation. All right, let me go through one last problem, and that's this rotation with a dilation. So again, I'm going to start with, this time you have an x, y, z, so I'm going to do x prime, y prime, z prime. I'm going to do a rotation of 90 degrees about the origin. If you go back to your note card and look up, the rule for rotation 90 degrees, it's negative b comma a. So that's what I'm going to use. So what this is I'm going to basically switch them, and I'm going to multiply the b or y value by a negative. So multiply the b value. So that's what I get after my first transformation, which is that rotation. Now I'm going to multiply everything by 2/3 because I'm going to do a dilation. So I should be getting a smaller image because it's a reduction. So if I multiply by 2/3, what do I get? So that's negative 2, so negative 4, and then 6, and then this would be negative 2, and this would be 2, and then this would be negative 4 and 2. All right, I'm going to go ahead and graph the original and then graph the final image, and then we should be done. So 9.6, 3 and 3, and 3 and 6. So it looks like a right triangle here that I have originally. Remember, this should eventually, so we rotated it and we made it smaller. So -4, 6, -2, 2, and -4, 2. Okay, notice that it definitely did move, right? Well, it didn't translate, but it rotated. And we also made it smaller because we did the dilation of 2/3. All right, I would try the lesson 4.5. I would try that and then obviously come to class with any questions. And if I were you, I'd also maybe go back and try some of the extra ones. We'll try to do them in class, but just in case we don't have time, but you can always try the extra problems on the extra practice that I did not get to. All right, let me know if you have any questions. Bye for now.